design, engineering, manufacturing, sales, service, marketing, and customer experience. His team is focused on developing immersive business strategy and delivering innovative solutions. Today, Jess will share the GM's story about where the immersive technologies are successfully utilized in the automotive industry. Please join me welcoming our keynote speaker, Jess Bradman.
Thank you, Heijin. My screen.
Welcome.
Thank you. Let's hope that I can figure out how to share my screen here properly. So let's see if this works. Yeah. Are you able to see a GM slide?
Yes,
great. You can see it. Okay, great. So thank you for that introduction. I'm Jess Bradman from General Motors, and I'm really happy to be here. Thank you for inviting me to share what we're doing at GM. Okay, so real quick overview. Our team is broken up. Brian Stiles on the left is my boss. He oversees all of immersive technologies for General Motors. We have counterparts on the information technology side that we work with in terms of any types of custom development or implementing enterprise solutions. You have me in the middle there highlighted. So my team is business strategy and innovation. We are like the tip of the spear. And we collect all the new use cases, we collect all of the problem statements, and we help to feed this process in the ideation phase. And we move into starting to proof of concepts. So that's Dave's team. We have an immersive innovation lab where his team works, and he has a number of different immersive engineers that help us solution. And then at the end of the process here, we have production and our asset creation team. So these are the folks that are really utilizing the tools in production and creating all different kinds of assets and different visualization reviews. So that's just a high level breakdown of how our team works at GM. So I probably don't have to explain this to this group because you're all experts, but this is kind of an introductory slide that shows some examples of different immersive technologies that we have. Let me see if I can minimize this window here so I can read my slide. There we go. So headsets, computers, software, tracking, these are kind of the major components. So you can see here that General Motors, that's actually a picture of our lab, by the way. General Motors uses all different kinds of solutions. And really what's important to us for immersive technologies is this is a great saying here: if you tell me, I will listen. If you show me, I will see. If I experience it, I will understand. And this is something that we really struggle with as we're trying to move into virtual solutions from physical prototypes at General Motors, is to really be able to connect the dots between what you would get with that physical experience, but the speed and agility of working virtually. Another aspect that we're looking at is how fast this technology is growing in both the consumer space and the enterprise space. You can see that the sales of headsets have grown exponentially, and there continues to be a growing market with more technologies coming online. So this is another trend that's leading us to understand that this technology is developing at a fast rate, and General Motors wants to win in this space and harness all of the capabilities that come along with that. So our driving factors are really our accelerated vehicle development timeline. And you might see it called out here. I tried to remove as many acronyms as I could because we love acronyms at General Motors. But if you see anything that says GVDP here, that's our global vehicle development process. And we're really looking to accelerate that with the battery electric vehicles that we're developing. We want to be able to get those out to the market much faster than traditional internal combustion based vehicles. So that's one of our major drivers. Another one is driving virtual. So that's kind of an enabler to drive the timing, is to be able to move virtually and get out of physical prototypes where it makes sense and into virtual prototypes as much as we can. And with COVID, of course, working appropriately. So we have many more people working from home, working abroad in different areas. And it's important to be able to keep that collaboration with teams going forward. So we want to, our vision is to make GM an automotive leader in immersive technology by implementing forward-thinking technology to our employees and customers that will transform the way we design, build, and sell our vehicles. So we always like to say, we want to connect what is to what is possible. And there's three major ways that we're going to be able to do that. Transforming the vehicle development process, finding a way to get on common tool sets wherever possible, and along with that, common data sets. So I'll give you an example here of how we can do that. So on the left side, we have our immersive group, and we're working with our advanced design groups. We're able to collaborate. We're trying to figure out ways, because the technology is great, but you don't have everybody that really wants to pick up the technology in the enterprise. So you have a lot of early adopters, but getting to that early majority is really where that chasm is that you need to leap over if you've read the book before crossing the chasm. So that's what we're trying to do here with this exercise. So we'll start with workshops and with some of these early adopters in our advanced design groups where we can take risks because it's so early in the process and still kind of conceptual in the vehicle development process. And we'll develop different work stream ideas. So one example here is being able to use different technologies to sketch and model in virtual reality. Or it could be integrating our typical physical seating buck where you can sit inside of a vehicle. We're trying to find ways to remove the physical properties and the foam and the prototypes and remove as much of that as possible and supplement that with virtual. So you still get all the touch points, you still feel like you're touching a car, you're sitting in a car, but we're able to supplement that with a lot of virtual stimuli. So this is just an example of a high-level global vehicle development process. We start off in our architecture studio, building the foundation and architecture of the vehicles. And we have kind of early advanced design work and vision work for the different brands. It moves into theme exploration, where we have different designers that are competing with one another to come up with the best design theme, and those get selected. And then, of course, once you get to a single theme, you want to execute on that, work with engineering to refine that, and then get into production surfacing. So this is just kind of the front design aspect of our vehicle development process. Obviously, it goes further into manufacturing and sales and other aspects, but I just wanted to show you really quickly a high-level overview of the different types of use cases that we have just in these early development process parts of the process with design. So anything from conducting design reviews to surface reviews, sketching and modeling I mentioned earlier. Color and trim is a big use case for us to be able to validate different color and trim ideas. We're doing different user experience prototypes in terms of driving the vehicle and interacting with the human machine interface. So all different kinds of use cases, and this is just one piece of our vehicle development process. So we want to make sure that we can help everybody else experience this event. So we held an event that we like to call Game Changers 2021, because we feel that this technology is a game changer. And it really helped our different leaders throughout the company, throughout the enterprise, get exposure to the technology, especially after, again, we've all been working remotely. We found a safe way to do this in our historic design dome. But we had examples of how to use virtual across all of our different aspects of our process. So I've got a short video clip that I'm going to share from that event. So hopefully the audio goes through.
Jess, we cannot hear anything, so could you please pause and then, when you share your screen, at the bottom, when you share your screen,
yes,
you have an option whether or not you're gonna share the audio as well.
Oh, okay.
So please go ahead and click the share screen.
Sound share. Yeah. All right. Just interrupt me if you still can't hear. I'm going to play again.
Great, thank you.
Is not just a technology for video games. It really is an opportunity for us as GM to transform our game, how we interact and communicate with each other, and also how we engage with our customers externally.
We feel it is important to speculate and strategize on where these technologies are leading us. We envision a future where this technology is with us at all times, seamlessly and contextually integrating the virtual and physical worlds.
This right here is VRED. VRED is a tool that's used to show surface models in proper color, lighting, and environment. So you get a lot more realism out of this. It's also one-to-one scaling. It's a VR tool that we use in design to make evaluations and decisions. What this allows us to do is either by desktop or HMD get into a single session with multiple users around the globe and view this vehicle in one-to-one scaling and everybody viewing the same thing at the same time.
Bringing the components, the designs to you in your house or wherever you're physically located is of extreme value.
It will also allow us to do things like safety. Imagine looking at an airbag deployment and actually being able to sit in the vehicle while this happens. No cameras can capture that, but you can pause it, you can rewind it, you can take slices and look at it in the virtual space, and that's going to help us get safer, better products to our customers.
Here we have an example of the Cadillac Lyric program. See how the airbag is interacting with other parts? This is not possible in a physical test environment. No matter how many cameras you get in the lab, you'll never be able to get these vantage points. You can see behind the scenes of an airbag deployment. See how the airbag is interacting with the headlight or the body structure, the pillar trim. Insight like this allows us to quickly iterate solutions to assess potential risks and keep safety our #1 priority.
Immersive is key for understanding CAD and bringing it into our real build situations.
We found over 150 potential issues, including math and design issues, issues with tooling and how they interface with parts, issues with the build sequence or parts layering, and additionally issues with ergonomics.
Obviously, as we're designing parts, we have to think about how we're going to assemble these vehicles. And the technology that's gone into the virtual reality for manufacturing really helps us validate the designs are good instead of waiting for a physical property and doing physical builds. And then we get rework at the end that may not meet requirements. Now we can validate that virtually and move and go faster.
The Immersive team has been developing our math to model pipeline within marketing. And the idea of math to model is that we leverage the engineering math, optimize it, and create essentially a marketing twin of the vehicle. Right now it's being used here in the visualizer. This is on the Cadillac website right now.
From a long-term perspective, I really think that technology is going to become a much bigger part of the customer shopping experience, where customers can see technology and experience technology from their home, where they can connect with a dealer, talk to them virtually before they have to go into a dealership to try something.
If you're familiar with Viz Mockup, visualizing data, cutting sections with data, there's a whole new dimension now because we can actually do that in full scale and in 3D.
That's been one of the big questions that's continued to come back is, how many people are seeing this? How can we get more people to view this and experience it? Because it's one thing as we're working from home and working appropriately to try to explain stuff with PowerPoint slides, but it's a totally different thing when you can actually experience it. It's like what we've talked about with the whole Moments That Matter model of when you can have an experience that forms a belief, those beliefs drive actions, and those are where the results come from. And what we're doing right now is really laying the groundwork with those experiences to help really transform how we think and how we work.
There is a cultural element. It's about being bold enough to let go of what we've been doing today and embracing what's possible tomorrow and feeling comfortable with being uncomfortable with these technologies.
What you really should walk away with is how immersive technology, the breadth of it goes across the enterprise. It's not just focused in design. It's not just focused in product development. It's not just in manufacturing and SSM. It goes across. So it really leverages this technology on how we can do business different all the way across GVDP.
All right. Hopefully the video was streaming okay for everybody, so I'll keep going here. So just to kind of help explain, how our team started, essentially before we would have all of these different ideas, these different vendors, people going to trade shows, they had all these great ideas. You multiply this by, many people within General Motors that really want to be innovative. They get energized by all these technologies. They really want to go do something innovative. But the end result, of course, is that when it comes to purchasing and IT support, it just becomes a massive headache to manage, terms and conditions and licensing and contracts and all these different things. So we really decided that, we need to find an enterprise approach to this. So this is kind of how our team started. So what we did differently is now we're going out and we're identifying and filtering through these different vendors, and then we're collecting all those different use cases and opportunities from our internal customers. So we're able to partner with strategic vendors and prioritize, and then find overlap between these different domains and different customers within GM, whether they be designers or engineers or marketers, whatever their role is. And then we try to find best-in-class solutions that are really sustainable at an enterprise level. Here's an example of what I was saying about finding overlap. So this is a bit of a Venn diagram. So you can see kind of the colors overlapping with the different departments or domains within General Motors. You can see that especially in the center there, something like haptics and interaction with gloves, or mixed reality overlay for contextual information. I mean, these are just technologies that everybody needs. They benefit everyone across the enterprise. So this is how we begin to prioritize and focus in different areas. This is a great example of working appropriately. So this is all of our team actually kind of doing a mock design review. So that dome that you saw earlier, this is the virtual version of our dome, and we have a Corvette in here, and these are different folks on the team just kind of doing a design review. This is our patio. The funny thing is this was the only way that we could do a design review on the patio, because currently our facility is under construction and this patio has been torn out. So this really helps us continue on with our design reviews. Another issue that we face that I mentioned earlier is common data. So we have you'd think we have the design phase, the build phase, and the sell phase. And there's all this CAD data that we're generating, and there's all these great shaders and different materials that we're scanning in. Things like physical attributes like mass and how gravity affects them. Even how we're building our infotainment and how we're configuring our vehicles for sales. And the issue is that you'd think we would have a nice left to right process here, but realistically, our data pipeline isn't built for high-end visualization. So we have a lot of churn. We have different things that don't convert properly. We have different things that are incompatible, duplicate effort. We have to outsource a lot of work in terms of manual preparation of data for visualization. So ideally, we want to streamline this, of course, from beginning to end, and as much as we can align on a single data prep process that enables as much automation as possible, because that's really the key enabler for this type of visualization and immersive tech. So a little bit of high level, I'll go through this quickly around our process. So my team, we're focused on business goals and strategy. So we develop the charters, we frame up the projects, the scope, the deliverables, we conduct workshops, we do capability roadmaps. Our lab then is working in parallel with us, developing tech roadmaps with those strategic technology vendors. We're doing demos, we're doing testing, we're doing benchmarks. But in some cases, it's really a chicken or the egg, because sometimes you'll have technology that influences a new use case, or use case that asks for new technology. So they kind of go hand in hand in terms of timing. Ultimately, we want to funnel that into technology solutions, like I was saying, that are sustainable. We do that through proof of concepts to test out these different theories. We do pilot testing in production after we've gone through a proof of concept. And then we start to work with IT in terms of making it a standard that someone can order from our IT store. This is an example of one of those capability roadmaps that I told you about. So going from left to right, these are called our different work streams. So these are the kind of the major work streams that we have for our business capabilities that we're looking for. So you can see there, I'll just call out a couple examples. Not only do we want to go fast and be able to buy off the shelf solutions when necessary so that we can show progress and learn, but we also want to build this enterprise solution that gives us something that's end-to-end, that has that data pipeline that I was mentioning earlier. Here's an example of one of the POCs, or proof of concepts, from our lab. So we did an actual side-by-side kind of digital twin with the Vario XR3 headset. So what you're looking at there is a digital bolt as well as a virtual bolt side by side. So I'll let you look at the top one and you can tell me which one's the real car and which one's the virtual car. And then, so the next piece here is a video that we worked on. This is our future vision of how we want to work. You saw a sneak peek of it in the last video, but I'll go ahead and play this for you and then we'll talk through this. So that was a really fun video to make. Everybody in that video was a GM employee, and we filmed those at real locations, different facilities around our campus and off campus. So obviously it is a future vision. Those aren't real technologies today, at least the way that they're being shown. So I kind of want to go through and highlight some different missing elements. So you probably have noticed some of these, being experts in these different fields, but you know, we don't have these types of sleek glasses yet. I mean, probably one of the best examples is on the right here with the Magic Leap 2. We don't really have these aesthetics. We don't have the comfort that we're showing here. A big issue too, of course, is battery, visual fidelity, field of view, sound capability is actually getting better. But so that's the first thing I wanted to point out in terms of where we need help in developing better solutions. The next is the input devices. So you saw one of our designers there using a stylus to actually sketch in mixed reality. So there are different solutions out there, of course, but they still require outside-in, you know, valve-style tracking. They're not really integrated with an inside-out tracked headset at the moment. So we don't really have a lot of flexibility on those different things, and those are still kind of really early in their development. You saw one of our engineers grabbing a hologram of a headlamp and then kind of putting it into position. You know, we just really don't have that type of haptic forced feedback in that type of form factor. There are great solutions out there, but they are bulky at the moment. And then integration in just your day-to-day. So you saw an engineer on their computer with augmented windows around their monitor. You know, there's still going to be a lot of working with traditional computing tools, and we just don't have that kind of seamless integration right now. It's kind of all VR or nothing. But there are some solutions out there that are looking to grow on that capability. In terms of software, I mentioned how important data preparation automation is and getting that as smooth as possible so that the assets are ready to go, their product correct, and you can interact with them without having to go through the manual labor of prepping data. Integration with our tools, especially if we can get it into the UIs that we were showing to make those really intuitive. And then, you know, the killer app, I think, for immersive technologies is artificial intelligence and being able to provide you different guidance and options as you're trying to engineer the vehicle. That's really going to be a great coupling of different technologies. In terms of collaboration, we have great collaboration tools right now. They're definitely not as integrated as we were showing here with the different avatars. And of course, the avatars of today are not what we have in this video. So continuing to be able to improve on those and make them more realistic and representative of the people that are trying to collaborate. So there's a lot of help that we need in the industry. I'm sure other vehicle OEMs are in need of some of the same technologies as General Motors. But I will say, you know, we are hiring, and we're looking to find the right people to help us in this industry. And please visit our website and apply it to any jobs that you might be interested in. So that's what I had for today. I think we have a portion here for questions as well.
Yeah.
Great.
Thanks for your great presentation, Jess. I got very impressed by the fact that the immersive technologies are actually transforming the vehicle development processes from design to engineering and manufacturing, and all the way down to the sales and marketing, even aftermarket sales services. So yeah, and now it's time to take any questions from the participants or any comments.
Just in terms of the last slide, are you looking for any student internship?
Yes.
So do you have any internship opportunity for students as well?
Yes, we have opportunities in our immersive lab where we've hired game developer skill sets, folks that are good with dealing with VR hardware and testing out and benchmarking different technologies through a scientific method. We use a lot of different methodology for that, but and then we also hire interns for asset creation. So again, any type of prepping the data to do reviews. We're doing a lot of custom work in Unreal Engine as well in terms of, whether it's a customer clinic or a design review. We're doing all different kinds of work in those spaces.
I think Tom has a question.
Hey folks, just great videos, great presentation. Really interesting explanation of some user needs there. Really interested to hear you talk a little bit about all the platforms you're using, and if that's split across teams, if that's split across, like, do different teams just choose the platform of their choice that meets their need at the moment, or are like, is one team using, I saw like VRO, and I saw an HP Reverb, I think, and I saw like Vive Pro in there. What drives those choices, and how are you trying to get down to one platform to help that transition that you're talking about, or is it, what's the process there?
So in terms of hardware platforms, we do have different standards for different use cases. So for example, when we've been setting people up with laptops to take home to do their own VR, if they don't need to do a lot of sketching and modeling in VR, where hand tracking is really critical, we can give them something like a Vive Cosmos, right? Or something equivalent to that has the inside out tracking to just kind of ease the setup and mobility of what they're trying to do at home, and bringing it back to the studio and back to the office. You don't want to have those lighthouse tracking devices to drag around with you. So in that case, when it's focused on mobility for virtual reality, for fully immersive VR, we do that. Kind of our standard go-to is like a Vive Pro or something to that effect that has that outside-in tracking. Obviously, we continue to look at other hardware as well as it comes out and benchmark that. But that gives us more accurate controller tracking for that sketching and modeling use case, as an example, or anything where you need to really track where the controller is very accurately. And then, in terms of the Vario headsets, they bring all different kinds of new features, whether it's mixed reality, to be able to see your surroundings, or mix a virtual prototype with a physical prototype for ingress-egress studies. Of course, there's the higher resolution aspects to the XR3 as well that allow us to do things like exterior design reviews. You can imagine, so if you're doing an exterior vehicle design review, our design leadership team likes to stand very far away from the vehicle to kind of see it from a distance as opposed to standing up close. We need a lot of pixel pitch to be able to do that properly, because otherwise it gets really grainy and the resolution isn't good. So it really depends on the use case. That's how we solution it. Hi, I think you're on mute.
Yeah, I think William has a question for you.
Thank you. So I work at Air Force Research Lab, run a lab there. And one of the issues that we have is dealing with a lot of our contractors with data interoperability between engineering systems to delivery presentation system. So I just was curious, what kind of exchange platforms are you using? Do you find them good enough, or do you find yourself in what I often see, huge teams in dealing with animation, deployment, something changes upstream in the design, and then you basically have to redeploy a whole group of artists in animation development. Do you see any issues with the current standards like GLTF, Collada, et cetera, in achieving that kind of data interoperability? I hope my question made sense. Thanks.
No, it makes sense. Yeah. So General Motors has such a wide range of use cases and current off-the-shelf tools that we use, right? So if we're using a tool right now, and all of a sudden there's a virtual reality plugin for it, and we can keep it in its native format and not have to do any data translations, we try to do that because it's just easiest to do it that way, right? But in cases where you need to do more of a high-end visualization review and you need to do the data preparation, you're absolutely right. There's not really one format that really works. I think there's been a lot of great discussion around USD in terms of what that's going to bring to be able to kind of stream different models without having to do anything manual, to be able to kind of script all of those translations over. So that's something that's of interest right now. But we already have a standard JT format that we use in terms of all of our CAD data going into that. But making that JT usable for all of our use cases obviously becomes difficult as well. So you have to do some translations there. So I don't think there's a silver bullet right now, and that's why it's one of our major strategic areas that we're developing.
Yeah, thanks for answering. If you want to talk more, we are investing in that area. Thanks.
Cool, thank you.
Okay, thank you, Jess, for your presentation and answering the audience questions. As a timekeeper, we need to move on because we have a schedule. So the next one is ice-breaking time. So we will make a break room 4 or 5. So we will make it and invite you, and you guys feel free to enjoy the time with a small group. So let's
give me a second, please. I mean, I just have a question about the schedule, because isn't this until the 50, not 40 or something?
It was 40 minutes. So yeah. Oh,
yeah.
You're right. We have 6 more minutes. Sorry.
Yeah, we still have time. Yeah.
Okay. Yeah. Great. Sorry. Nicholas has actually one question in the chat. So Nicholas, could you turn on your microphone and ask the question? Or just okay, sure. So Nicholas' question is like data preparation for visualization and eventually manipulation in immersive technology is a major problem. How far would you say GM is in automating those processes for smoother integration of XR in current workflows?
Wow. Well, it's similar to the previous question as well. It's hard to measure how far we are because it's such a complex topic. I would say that we're still in the early stages, but we have a really good plan for how to do that. It's just a matter of finding the right partners to be able to get the right conversions going. And it's not even so much just the CAD data, it's also all the other metadata that comes along with that. In terms of, how do we assign materials in an automated way? How do we assign physical aspects so that when we interact with the data, it's reacting physically, training information, animations. So the CAD data itself is a big issue to solve, but then we have all of this additional metadata that we have to handle as well. But it's hard for me to say how far along we are, that's a difficult one to measure. We're not there yet. Let me put it that way.
So, okay, I have a question for you. So here we have people from industry as well as people from academia, researchers. So you already talk about the gaps between the vision and the reality, right? And what would be the most important challenges that the research communities may work on to help auto industry get most out of the immersive technologies?
Well, for General Motors, I mean, I think just getting to a virtualized lightweight headset, like I was showing in the vision video, I think is going to be key. I mean, trying to have the high-speed network in place to enable all of those use cases that I was showing, because trying to get all of that computing, on your person, with the battery pack and with everything is really the biggest issue with the form factor and the comfort, the weight, the heat, the cost. So, I mean, getting to a point where you can do what we're showing in that vision, I think the network infrastructure and computing infrastructure to basically turn the headset into an edge device as opposed to a standalone computer with all of its own processing power. To me, that's probably the biggest hurdle, but I know that there's a lot of developments in that area. It's just going to take time to get the network to be able to, not have latency issues and all that kind of stuff. But to me, it's just going along with the mobile 5G infrastructure that needs to be installed, around the world, that's going to be probably the biggest hurdle for everyone. I think the headsets are going to catch up probably before that happens.
If you don't mind, I can ask a quick question, because I mean, my question might be somewhat related to the tough question that you answered before about the how far you're in the automating those processes or something related to the data preparation for visualization. In the presentation or the video, you mentioned about like a digital twin, that kind of concepts. I was just wondering how, what kind of like a digital twin, how in depth you're actually using that kind of digital twin. I mean, when you mention digital twin, is that just like a virtual, like model of the certain like component in the car, or is it really simulating the real like a component behavior in that level? I don't know. I was just curious.
Yeah. So the example that I showed is a bit of cheating, I guess, in terms of the terminology of digital twin, because ultimately a digital twin should be a persistent model that's always updated as you develop the product. And that was not what I was showing. I was showing a digital twin in the sense of a point in time when the vehicle was mature and we prepped the data that you saw. But the reason why I said digital twin is because we put them side by side with mixed reality. And then we asked people to do a comparison of, hey, is the blue the right color? Is this leather the right color? And it was really, it validated for people that there was no distortion in what they were seeing, because a lot of people are afraid when they look at a car, especially an exterior, that it's going to be distorted because of just the history of virtual reality with caves and power walls and distortion issues. So that was a bit of a validation for the hardware itself. And then also the color and trim quality. So we have a high-end scanner that we do material scans in, and then we post-process those. So it was also a validation for the material shaders themselves. So I cheated a little bit by saying digital twin because I think that has a different meaning for a lot of people.
Yeah, thanks a lot.
No problem.
Okay, actually, this is real time's up. But thank you again for Jesse for your presentation.
Thank you.
And let's move on to the next one. So currently we have 26 participants in this room. So we want to break out, we want to have a breakout room. Then could you set up the breakout room? So I'll do it. Okay, so we will create 5 or 4, maybe 5 rooms. So each room will have 5 to 6 people. Then, okay, then please come back in 20 minutes. Then enjoy this ice-breaking time.
Modal displays, things like that. During my time there, I ventured into some industry work, working at Google X, and then ended up coming over to Seattle to work on the HoloLens 2. This is before HoloLens 2 was announced, and I got to work on the hand interactions, which is really, really fun project. From there, I've worked on a number of other devices, Windows Mixed Reality VR headsets, IVAS, for those who are familiar with that. I've touched on that project. My focus within mixed reality is the input and interaction topic. So really understanding how people interact with the AR and VR technologies, how they complete the tasks that they need to do, the controllers, hand tracking, speech, all the alternative sort of explorations, like we saw some eye tracking stuff there. Very cool to see that. Yeah, some really good stuff there. And then I've also kind of started up this work that sits between human factors and user experience, which is called hardware experience, really understanding what are the scenarios in which our users find themselves when they're interacting with these or using these devices, and what does that mean for what the hardware needs to be? This was born out of a few different programs, but you can imagine how important that is, not just for HoloLens 2, like Trimble project, which we'll talk a little bit about, but also something like IVAS. And then accessibility. Accessibility is huge. It's an area that is finally getting its day in the light. in mixed reality, and we're really excited to push the forward going into the future. There's a lot of good work happening on accessibility in all of the MR space, and I'm really excited to make that make it accessible and make it equitable for everyone who's using these technologies and who should be able to use these technologies natively out of the box. So really excited to be working on those topics. All right, so for today, we're going to talk a little bit about HoloLens 2, but what I want to talk about is I want to talk about how we're using inclusive design and accessible design to build the best user experience regarding input that we can. Now, when we think about HoloLens 2 is built for people in the office, but also people on a factory floor. And those are two very different users in two very different scenarios with two very different capabilities. And so we have to understand what those are, and we need to design for those people, not just in hardware, as you see here, but in interaction methods. And part of the work that I've taken on and I've worked with a large group of people within my organization is to go after understanding this and go after figuring out the best way to enable people to complete all of the types of tasks that they might need to do. So I'm going to show a short video here. This is Julia Schwartz. She's a legend. She's great. Anyone who's gotten to meet her or interact with her knows this. Anyone who hasn't, you should. She's awesome. So it's going to kick in.
Now,
Wait, that's not working.
I've seen many people put on HoloLens for the first time, and the first thing
Everyone hears
people
it?
do when they put on the device is they reach out their hands and try and touch the holograms. And now you can. Look at the way that the hologram's responding to my hand, almost inviting me to touch it. And in fact, I can just grab this corner to resize it. Or I can rotate it, or move it. That's right. We are touching holograms.
So I'm going to pause it here. We're touching holograms. This was the big thing. Like, I came in and they're like, hey, this is the thing that we already know. People want to interact. They want to, you put a HoloLens 1 on them and they just try and touch it. And then when you use a HoloLens 1, you can't. Your hand goes right through it. You have to like target with your head and you pinch and then you drag. And they did what they could with the technology they had. But when I arrived, they were like, hey, we're going to do this. We're going to do hand tracking. We're going to let you grab and interact. And it was great user research to drive to that need before I even arrived. And I got to then take this like knowledge, just there's one of those stand on the shoulder of giant situations. And like all these people before me had done such great work, got to jump in a team with Julia and these other people to go do this work. And it's great. And I'll show a little bit more here.
This is an app I've got called Spatial. Let me just put it right there.
I've
got another application. I've got a browser over there, but it's kind of far away and I don't really want to walk over there. So let me just call it over with my voice. Follow me.
Now this is the other key.
This is a browser.
There's more than just hand interaction. It's multimodal. Not only did the speech work, but it knows where she was looking to know what to activate with the speech. And so by using this fusion of modalities of understanding what humans are looking at, grabbing, speaking to, we can do a lot of great stuff.
That's running Microsoft Teams, which is a tool that we use back home to collaborate. Let me see what the team's been working on. Okay, it looks like they've got a surprise for me in the playground app. I just have to say the words show surprise. All right, so let me just here's exploring and refining interactions for HoloLens 2. And the playground is just a tiny sampling of the many prototypes that we built, tested, and learned from. Our approach is
This was actually something we built, tested, and learned from.
basically to try out as many things as we could and look for the things that stood out. So for example, here I've got 3 sliders. Each of them is controlling this wind farm simulation, but each in a different way using a different interaction technique. One of the things we tried is this touch slider here. So here I can just stick my finger in the slider and have it go to a particular value to control that wind speed there. It felt okay. We also tried this push slider. So this guy can kind of nudge from side to side, kind of like.
And so what she's showing here, I'm not going to show the whole video. You can find this online. You just look up HoloLens 2 demo mobile world progress. And it's a great video. It's a great talk if you haven't seen it. It's a great introduction. But I'm going to go ahead and go to the next slide. and talk about kind of how we got there. And one thing I want to really talk about here is, that presentation was very focused on hand interaction, which was the new thing. But we also knew from what we call our human-centered approach that there had to be more than just hand interaction. So the human-centered approach, or human-centered design, or there's lots of different words for it, but it's all the same thing. You're taking in these user needs within an environment. You're taking in the business viability and the technological feasibility of creating that thing. And you try to create these user needs and outcomes based on that. You then take that forward and you create empathy, and you define these things with the designers who may not have this day-to-day interaction with users like user researchers do. And then we help them ideate, prototype, test, and then launch. And this launch here actually often means testing. It's launching into a prototype or launching into whatever. It doesn't necessarily mean launching a device. And this is a cyclical process. And this happened, as she said in the talk, many, many times before we launched this device. But what I really want to talk about is what an MR interaction really looks like, and how we get to those and how we create those beyond the standard that she was showing there. So if we look at this, hand raise, not something she showed in that video, but it's something where you can use something from far. So if I want to interact with a hologram that's further away, I point my hand and I see a hand ray come out. Other modalities or other mediums use a similar system. And first, this person has to look at the 3D scene. Then they need to view all the information, listen to it, understand the object they're trying to select. Positioning their body so they can look at it, raise their arm up so they can target the object. See the hover state, maybe hear a sound cue depending on the developer. Then keep the body arm and still and perform a gesture. So it's like a lot of steps when you really break down what's being required to do one target and selection. How is this supposed to work within a scenario where we're saying, hey, this person might be pretty busy doing something else. They might be holding tools. They might be looking at the car engine as the belt is running so their hand doesn't get caught in it. And they can't do all of these things. We need to ensure that people have other modalities of interaction. And that is really driven by what we call the Microsoft Inclusive Design Toolkit. And this approach, the idea is solve for one, extend to many. And the main idea is that there are 4, 5, maybe 6 categories of disabilities. And you have these permanent disabilities, such as someone who has limb loss and has one arm. But there's also a situational disability, which many of us are familiar with at home. If you have a baby or you have a child that you need to hang out with, or a cat who happens to wander across the keyboard and you need to pull off in the middle of a meeting. Well, you still need to interact with their content, whether it be your keyboard or your AR content. So these permanent, temporary, and situational spectrums really help us understand the full extent of which users may experience throughout their time using these devices. So someone who maybe has an ear infection. Well, if you've already solved the interaction for those who are deaf, then you've solved for the ear infection. Or if you've solved for a situation where someone literally cannot see the content in front of them because they're blind, well, then you've solved for someone who is in a factory and it's very, very bright where they are and they cannot see that content because the AR display doesn't work, or they're, as I said, looking at the belt and they are seeing it spin and they're watching that, but they still need to interact with these holograms, interact with the guides, for example, of what's happening next. So the whole idea here is solve for one and extend to many. You solve for that worst case scenario and you can carry that throughout that whole spectrum of individuals. So if we take this a little deeper into the mixed reality space, we can start to define some of these. So we have actually broken apart hand and mobility. If I go back, you'll see here the mobility or touch is one category, but we've broken that down because in mixed reality, you have so much focus on your hands, whether that's using your hands actually in the air, whether it's using a mouse and keyboard, whether it's using a controller, So we broke that out from mobility itself, but mobility is also important. Being able to change the level of your floor or where you stand against that floor in a VR space or an AR space is just as important. Or if you can't pivot in some way because of you're locked into some small enclosed space and you can't turn your head, or because you literally cannot turn your head because you've got a neck brace on or whatever it may be. By solving for that worst case, you can solve for all those other, you can apply it to all those others. So this is just a list of some of those situations that we can solve for and we can apply this towards. So if we take this and we apply it into, let's say, a factory worker. This is the Trimble headset. If those don't know what that is, it's a modified HoloLens 2. Goes onto a hard hat, and it has also the addition of a couple of things. One of those being actually these little guys back here, which are bone conduction audio speakers. So let's take that, for example, a loud environment. Factory workers in a loud environment, they have this problem that they cannot hear what's coming out of these speakers. The speakers are pretty loud, actually. It's like very loud. So usually you can hear it, but let's say this guy had earplugs in and it's very loud and you can't. Well, we have the alternate auditory representation in this hardware model because of the bone conduction, so that solves it. Or let's say that doesn't exist for this one, or you're in VR, whatever it may be. We also have closed captions. If you look at Teams, you can close caption everything live. You can show that on lots of different modalities. Then there's also the ensuring that you can show visual cues to supplement audio, not just relying on one modality of information, but mapping it across multiple modalities. Another example, let's say your hands are busy working with tools, or you're in a tight or a snag hazard environment. You can't really like reach out and grab a hologram if there's a blade spinning right in front of your hand. So like you can't really design around that. Well, how do you work around that? Well, you have speech interactions, or you have alternate targeting mechanisms like what we saw earlier that eye track can work. Or if you look at guides, a gaze and dwell sort of situation where I just target my head and there's a head cursor and a timer goes and it selects. Or let's say you can't take your eyes off the task, or it's a bright environment, you can't see the display. Well, you have auditory feedback, and not just regular auditory feedback, but you got auditory, spatial auditory information that you can use at your disposal. So these are just some of the examples that you can employ within this situation to ensure that people are able to use a device, an AR, VR, MR device, within any scenario that they may find themselves in. And this is particularly useful, sure, within a factory, but it's also super useful within a home, as we talked about earlier. If your kids are in the other room and yelling, closed captioning is a super useful tool. And I think we're gonna start to see these things really appear more strongly as we go forward, beyond these occupational situations, but these situations where people are using it for personal entertainment or personal interactions. And so this is just hoping to point people to this sort of thinking of solve for one, extend to many. And by doing so, we're not only making our technologies accessible for everyone who have these permanent disabilities, but also you're applying it to so many situations in which these users are in situational or temporary disabilities that can really impact everyone's lives. And this is kind of the thought process that we're really applying within our organization, that we're trying to apply within our developer organization, and that we hope to really encourage others in the industry to start thinking about, because we can't just rely on two modalities of input going forward. If these continue to get integrated into our workspaces, into our homes, and into our lives. So that's all I have. I want to leave a lot of time for questions. But first, I want to just throw a shout out to my collaborators and just list out some related projects for those who are interested. Mixed reality user research team, massive team of people, lots of designers as well. There's a V team of accessibility people on there, MSR, Xbox, a couple of great tools, Soundscape and Seeing AI, if you're interested in these alternate interactions or how to use certain sort of tools to really understand the world around you. Project Tokyo is a great example of that from MSR. Xbox assistive technology or accessible controller, lots of other tools as well. So with that, I want to just end the talk and really open it up for questions around this topic or anything else that people want to talk about.
Thank you, Tom. We have enough time for Q&A. So I see Bill raised hands. You know, go ahead.
Thanks, Tom. Really interesting. So how does your inclusive design toolkit relate, if it does relate, to autonomous mobile manipulators and cobots and human robot interaction? Thanks again.
Yeah, no, that's a great question. I think, so to be totally clear, there is not a direct parallel between the robot interaction and this sort of stuff, but I don't think that it's impossible to connect those dots. I think being very clear, like if we look at, and by the way, if you just look up Microsoft Inclusive Design Toolkit, you can pull the information for this fairly easily. But if we look at the spectrum of individuals there, the spectrum of situations and disabilities, and you understand what is a user trying to do with a robot, then I think you're able to kind of connect those dots. If it's that, hey, I cannot interact directly with that robot and do what it needs to do, or I can't see what the robot is doing, or these other factors, that's great. I think if we're talking about just like robots doing these sort of tasks, I'm not sure it's directly applicable, but I think if you're doing human to robot interaction, there's definitely some parallels you can do there. Like if you can't speak to the robot, then how do you still communicate? Definitely some parallels in how we go about that.
Kang-Soo, go ahead.
Yeah, such a nice talk. Yeah, thanks a lot for sharing all this stuff. And my question is, what will be the next step then? I mean, you show like all these natural user interactions, but some of the researchers in this field, VR and AR, also look at like brain-computer interface, that kind of stuff as well. But in your opinion, what would be like a next step in like a few years from now?
Well, I know what the next step is, but I can't say necessarily. But no, I mean, there's definitely ongoing work in lots of spaces. I think there's a lot of good groups out there who are doing some great work. There's a group called XRIOS that is really focused on accessibility within the mixed reality space that I think is doing awesome work. And they'll publicly talk about the work that they're doing and really advocating for. If you were to looking at like, how does a human interact with, let's say, a computer right now who's blind? You use a screen reader, right? You use a screen reader. And if you can't use a screen reader, like you can't in any mixed reality headset right now use a real screen reader. Like how do we get to that point? How do we understand like what's going on in the environment around you in mixed reality? How do I do those sorts of things? There's also the question of how do we get people to use things like the Xbox adaptive controller or tools like that for interaction. You know, the Xbox adaptive controller can't replace a 6-dove controller, right? It's meant to replace a gamepad. So you miss out on some of those hand movements. Is that enough? Do you need those hand movements? Maybe not. It depends on how it's designed out. Can we get someone who can, you know, use scanning behaviors in a single switch, like some people have to for computers based on their abilities or disabilities? How can we get that to work within a mixed reality environment? That's a tough task, but it's something that we need to go do, and we need to figure that out and then apply it to these other scenarios. I mean, if we look at the iPhone, like the iPhone is the most popular assistive technology out there in reality, right? How do we use that model of what they've been able to do and apply it to XR? And what does that mean for the future? I think we saw earlier in the talk, in the session, we saw, you know, that demo from GM with like all these little glasses like mine, and they had AR displays on them. Well, what else do those have on them? You know, right? What other sensors are on that thing, and can that become an AT? Potentially.
Sure. Thanks a lot.
I have a follow-up question after Const's question. So you have been talking about the inclusion, right? That accessibility, but the current, one of the challenging or drawback of the current headset device, especially HoloLens, is the cost, because it's quite expensive, $3,500, right? So if you make more accessible, the reducing cost is like one of the keys.
Yeah.
So maybe, you know, in the future, then there are more, the more technologies developed and the more like a popular, then maybe the cost will be decreasing. But in how long, how do you think, you know, in the future, how, you know, how much you can get that stage quickly?
I mean, you can already get a mixed reality headset for fairly cheap, right? What does an Oculus Quest cost? Like $300-500 or so. Like, you can get a headset that maybe isn't a full like AR headset, but is a headset for that cost. You already have your phone in your pocket. I just saw someone's comment about your phone. Your phone can do AR. Let's not forget that augmented reality does not mean a head-mounted augmented reality headset, but this thing, and I have an SE, and this can still do, you know, target AR and show me what my couch cushion might look like if I buy that in my home. May not be awesome at it yet, but it's about economy of scale, right? And so as we, you know, how many people want to buy how many people want to buy one of these and put them on for multiple hours a day and use them and drive developer demand to create apps? And it's about this economy of scale. You know, the first cell phones were very expensive, but now everyone has one in their pocket. So it's just about creating, you know, silicon needs to become cheaper. Connections, as was called out earlier in the session, that needs to become cheaper. You know, all of these things will come out, figure out how we get there. Will be through economy of scale and through just popularity and demand for these experiences. And really, as people like, you know, all the different groups in the space, what do the users need? What are they looking for? You know, how can we improve people's lives? That will all drive that information as we go forward.
Haley?
Thank you, Tom.
Unmute and ask question.
Hi, perfect. Thanks for the talk. So this kind of leans into a little bit of the last question. So how do you think we should encourage or incentivize people to actually adhere to accessible design practices, especially since we've seen that with more mature technologies, like with phone apps, accessibility is often put to the wayside during the rapid pace of the development cycle?
Yeah, no, it's a great question, Haley. So, I mean, Haley's leading me a little bit here. So it's up to the developers, but it's kind of up to the platforms to enable those developers. For those who don't know Haley, you know, go look at her work. She works on developer tools for accessible design. That's what we need. We need people to make developers to make tools. Sorry, I should flare it. We need platform developers to make tools for developers on their platforms to better understand what they're doing. You know, when we're talking about these economies of scale, we're talking about iPhones, Android phones, these different applications, or even applications on your Mac or your Windows devices. Developers make those, and some are platform and integrated, but many are not. And if we're going into this store model, if we're going to this economy of scale model, developers that come from external to the company, to the platform, and make apps and sell them on those platforms, just like what we're seeing with Oculus and Steam VR and these other places, they need to be empowered and educated on how to do this, whether that's through documentation, and design guidance of how to design apps in an accessible way from those developers, or from the platform developers, or whether that's tools to enable them to test or build off of to make sure it's accessible. That's going to be key. Now, Unity, as we all know, of those who are developers, Unity is not like an accessible thing. It's a 3D modeling system. And so we have to figure out how to do that. And we have to figure out how to drive developers to, or enable developers of independent apps to make those accessible. So hopefully that answers your question.
Yeah, I sometimes wonder if, like, beyond just developer know-how and knowledge and tools, if there might have to be something like, I know this would be a terribly unpopular opinion, but it almost seems like you need regulation, kind of like what we do with mobile accessibility with buildings. But I can only imagine the storm that would kick up.
I mean, it does happen, right? If it's a big enough tool that enables someone, let's say, to do their job, right? And that tool is not accessible to individuals, and that tool is required to complete a job. I mean, there are situations where people can be forced to make those things accessible through suits. So, you know, it's something I hope we don't have to convince people of in an idealistic world. You know, from our side, we want to make sure that things are accessible and make sure it's inclusive and equitable for all of our users. So yeah, it's a really great discussion to have, though, and figuring out how to decrease the pain in creating those accessible tools is definitely a great first step. I don't know if it will be the last step, though.
Okay, great. Thank you so much, Tom. Let's give our hands to Tom again. And Heejin, you want to close the session?
I was muted. Can you see my screen? Yes. Okay. Thank you. Thank you, everybody. We appreciate your staying here for 4 hours until now. And this workshop couldn't have been done without your help and contributions. We really appreciate it. Although we closed this workshop now, we hope to be connected and continue this workshop next year, either at same conference, IEEE VR, ISMAR, HFES, CHI, or any other venue. Then, as you may notice, our workshop and organizers lack diversity. So we welcome volunteers and organizers from different groups and different countries for our more successful workshop in the future. So please feel free to contact us if you are interested in. Then we will keep you updated on our website. So please stay tuned and see you soon at the next XRIOS workshop in the future. Thank you.
Thanks a lot, guys.
Thank you, everyone.
Thank you.
Thank you so much.
Thank you very
much.
Good night.